Okay, we are at week 10 and welcome back. We're trying to follow up with combustion. So we did combustion, fuel for combustion, and how do we control the combustion. And now we'll talk about the draft. Draft is the air that's coming in and also what are we putting out in the environment. And I will start again with the equation of combustion because that's the basis for what we're doing right here. So we'll start with fuel plus air. And we say air is, hopefully you remember, 20% oxygen and 80% nitrogen. Plus ignition. And we will get heat, and the heat will deliver us some steam, plus water, plus what else? CO2, plus the other things that we don't like. Let's just put NOx plus SOx, sulfur oxide, nitrogen oxide. Nitrogen comes from the air. Sulfur comes from fuel. It's something that is there with the fuel that is not completely pure. We try to pay a lot of money to get sulfur out of fuel, but it's very expensive and it's very process intensive. Okay, draft. We'll talk about types of draft. And list type of draft, explain their operation. And now we are concerned with these two things in here. We want to know how we are going to get air in and also here. All this going to be included in my draft. We took what we want, which is the steam and the heat, and how do we control the other two things that we're getting in and out. That's draft. Air in and air out. Components reduce boiler emission. Compare the basic types of air heaters and explain the requirement for Clean Air Act. This requirement does change from one state to another, but there are federal regulations we have to meet and some local ones as well. We also talk about the criteria of pollutant named by the National Ambient Air Quality Standards. Again, you have to check with the plant and the local code for that. So natural draft, we talked about that actually in week 3, and we said it's air coming and moving by itself based on buoyancy. We know that hot air rises, cold air comes in. We can create natural draft that we do not need to move mechanically. By mechanically, I mean induced by motors and fans. So that's natural draft moving to a chimney. And chimney design is very intricate, and if you can see, it's kind of tapered because we want to keep the air at the right speed, depending on how long the chamber is or the chimney is. Forced draft is when we don't have the right geometry or the right mechanical structure to have the draft at the speed that we want it. So we put what's called forced induced draft, which is a fan that will try to pull in air from the room, from the ambient into the boiler. And this is going to be the case for a lot of industrial boilers because we are trying to supply the right amount of air into the boiler. So this is the air coming in from here, going inside, and this is the exit. All these components are in this step over here. So induced draft uses a fan outlet with a damper, so the damper control how much air goes in there. We can control how much air goes into the boiler using two things, either dampers, where we change the area, or a motor speed. So the motor can go slower or faster depending on how much air you want to have. For example, in your car, I keep using the car example. If you want to have more air, what are you doing? Either you shut off the vents to have less air, open all the vents, and if you still want more air, you're gonna increase the speed of the motor to pump more air inside the car. So a balanced draft, we will use dampers in the outlet and dampers in the inlet because we have a continuum of balance. Now this is my boiler. Whatever goes in must come out. So mass in will equal mass out. So that is the equation. So we want, that's when we call it balanced. So everything is good combustion and it goes outside. Of course, gas is compressible unlike liquid. So when it's heated up, it's going to have more pressure and more volume. And when it's cold, it's going to be denser and occupy less space. So we want to have balanced draft at the right opening. So if you notice here, they have the same amount of fans going in and out. However, some opening has to be bigger than other because the air coming here is much colder than the air coming out. So the air coming out has to be moving faster because it has more volume. If we don't have a balanced draft, probably we'll have a lot of leaks and a lot of back draft. If this fan is not dispensing all the air equally outside, some air going to go back into the fan and we'll have a lot of back draft. Natural gas and fuel oil draft uses forced draft for supply. Again, depending how much fuel are we burning and at what rate, we need to have this kind of balanced draft to equalize the air coming in and the air coming out. You don't have to worry about that too much. There's a lot of things to do with forced air, with coal, so don't worry about that a lot. Basically, it's trying to say that we need to have a balanced amount of air moving in and out based on density and heat. Heated primary air. Oh, okay. This again, we're still in coal. So the air that has to come and pulverize the coal and carry the coal with it has to be pulverized and warm. So that is another kind of apparatus that they have to use for coal to heat it, to heat the air, so it will be able to carry the particles of coal. So we can, again, it's the same thing. We can, if you see here this little damper here, that will reduce the amount of air coming in and out based on constant speed water. And again, we said there are two things we can use to control the air. I'll write them down. To control the flow, we will use either dampers or variable speed motor, more speed. So either we can increase the draft by increasing the speed or increasing the opening. Again, variable speeds, dampers or motors are used with fan motors to increase it back and forth. It's called variable speed drives because I've heard driving dampers, but it's drive because it's how we drive the inducer fan. Continuous monitoring. Okay, this is how we monitor the system sensors. So remember what we said, we need a lot of sensors to know how much air is coming in, how much air is coming out. There are sensors that will control the motor, so it will run automatically depending on how much CO2 are we producing and how much air is coming in based on sensors. So they have sensors to control the flow. They're called continuous emission monitoring systems. So based on the emission, so if the emission is too high, we can increase them back and forth the speed. Again, if you have some automatic AC in your car and you set the temperature at 70, you'll see that AC will start really high speed. Then as the temperature goes down, it will lower the speed. The same thing is happening here precisely. It will control the speed of the air coming out. And sometimes we need to cool the air before we dump it into the atmosphere. There are regulations how much temperature we can dispense into the atmosphere. And that's again a different field in how we can run the fuel gas into water, feed water to heat it and absorb more heat. It's not because just we want to economize the heat, it's because sometimes we are not allowed to dump a lot of heat outside in the atmosphere. Scrubber are used to neutralize acidic chemicals compound in the gases of combustion in order to reduce air pollution and also in water. So what are those scrubbers? What do they do? Where is the acid coming from first? So fuel. The fuel has a lot of sulfuric acid. When we burn the fuel, with the water, we'll have some dissolved nitrogen oxide and sulfur oxide. Those water and these components will produce acids. These are things that we don't want to, substances we don't want to dispense into the air or into the water. Remember when we used to have a lot of acid rain? It was because of the sulfuric acid. The particles of water and sulfur will go into the air and come back with the rain as sulfuric acid that will strip out your car paint, and it's really bad for the environment and for the plants. So luckily we have the Clean Air and Clear Water Act, so we cannot dump sulfuric acid into the atmosphere. So we can neutralize that using some chemicals. There's a lot of calcium rods and a lot of other items we can put to neutralize it and make it not acidic. That being said, we are bringing the pH level into neutral state instead of being more lower than 7. Dust controllers, collectors, remove flashes from the gases and combustion. Again, this is especially common with coal. There's a lot of particles that goes to the fumes. We want to capture all those particles. Again, there are filters, there are meshes, there are many ways to remove these things from before we dispense them into the atmosphere. If you look at this apparatus here, we swirl there so the particles that are heavier than air can settle down and get collected and disposed of properly. All this waste actually is being used. There are companies who use these wastes for other things, either making fertilizers or they can use it for other chemicals. So yes, it costs money to clean the air and water, but also there are some benefits to it, and plants are getting smarter now on ways how to dispose of this properly without a lot of cost. The convection heaters, again, we say we cannot just dump hot air into the atmosphere or hot water into the atmosphere without absorbing some of the heat. So those convection heaters actually help out a lot into like absorbing all this heat, and sometimes we can reuse them, which will make the plant more efficient. And again, there's a few stories about plants where they were dumping a lot of hot water into rivers, and that kind of changed the whole ecology of the river in terms of fish and wildlife. So now we have to like try to vent this heat properly before we dump heat into the air or the water. This is another way also to absorb heat and circulate heat and reuse it inside the plant instead of dispensing it into the atmosphere. These actually are becoming more and more useful now, even at residential level, because if you want to vent your house in the winter and you're dumping hot air inside the atmosphere, outside the atmosphere, the air at your house is around 70 degrees. So if you let it out completely, you're losing this temperature. So there are some smaller heat exchangers that will absorb that heat and bring it back at your house. So this is a means of just recycling the heat instead of dumping it outside into the atmosphere. Last but not least, this is a chimney for a power plant, and you can see it has a lot of involved particles here. Some stuff will absorb the heat and some stuff will try to filter out the ashes. There's a lot of requirement for environmental regulations that we cannot dispense air within outside of the limitations. And of course, there's a data being recorded by those sensors where they get reported to the EPA sometimes, and the power plant is responsible for keeping record for all these components. So the log, all these sensors here will send information to a log that is stored for month on end to be stored. So yeah, that's chapter 10, and there's few information about draft, and there's for the applied math, there's a variable speed drives math problem that don't worry about it too much. But the efficiencies are something I really want you to look at and tell me if you can understand. I mean, it seems very straightforward, but basically it's how we calculate efficiency. And if we look at the equations provided in the book, it's the symbol for efficiency. And if you can remember that efficiency is always output over input. So whatever you got out over whatever you put inside. And the number always has to be less than 1 or 100%, otherwise you probably just switch the output and input. All right, this is what I have for this lecture, and I'll see you next week.